Welcome, ladies and gents, to today's lesson. Chapter 12, Lesson 9, Graphing Linear Inequalities. More on that in a moment. Go ahead and pause, check your work from the previous class day. Come on back when you're ready. That was the first page. I'm going to zoom in, so pause out whenever you need. And to the second page. First problem was a multi-part problem. And below that. All right, ladies and gents. Focus for today. Action word is to graph. We're going to graph linear inequality and the solutions for that linear equality on the coordinate plane. Now, I'm going to tie this into a couple things. First of all, we have graphed lines before. Now we're going to learn how to graph a linear inequality and point out all the solutions. I'm going to tie it into another thing, and that is graphing the solutions for a one variable inequality. I want you to think about this. There was a time where we'd say, okay, one doesn't work, but all these other numbers were. And we said instead of drawing billions and billions of points, we would just draw a nice thick ray. We also said because 1 is not less than 1, that's a false statement. Do not fill in 1. But even 0.99999 works, but not exactly 1. Okay, so the point there is we can graph all the solutions, which in this case is infinitely many, on a one-dimensional line, number line. Now we're going to take it and we're going to do something like this. And we're still going to see so many solutions that we have to color it in, but it's going to be a little different looking, shall we say. All right, onward. So I'm going to ask you in a moment to pause after I talk through this and write these down. You do have a notes page as well as a homework page for today. Step 1, just graph the line. Use the skills, either using a t-chart or perhaps more efficiently using the y-intercept and the slope to graph the line. Now, you will use a solid line if your inequality sign has the or equal to, less than or equal to, or greater than or equal to. Because, as I will show later, all the points on the line do in fact make true statements. If they're solutions, we got to color them in and point out that they are solutions. However, you will use a dashed line if there is no or equal to bar, as in the less than sign or the greater than sign. Why? Because, as I'll show later, the points directly on the line will make a false statement. So yeah, we need to draw the line as kind of like a boundary, but the points don't work. So let's make it a dashed line to show that they don't work. Now, not only will there be some points perhaps on the line that'll be true, but there's going to be billions and trillions more points that will make the statement true. So we're going to have to shade a certain part either above or below that line. We're always going to test the point. Well, I shouldn't say always. Sometimes 0, 0 isn't great, but it is nice. If it is a solution, we're going to shade that side. If it is not a solution, we're going to shade the other side. Now, I will come up with certain examples, so go ahead and write down whatever you need, pause your video, and then return. Or perhaps you go on to the examples right away, and then pause and come back to this part and reanalyze that. All right, so let's get into a particular example here. We're going to be asked to graph the following inequality: y is less than 2x plus 1. So the first step we're going to do is we're going to just graph it like it's an equation where we can start with our y-intercept. So I'm going to go ahead and put that positive 1 directly on there. And then we're going to use our slope. Because slope is a rise versus a run, let me go ahead and just put a 1 in the denominator. Now we have a rise of 2 and a run of 1, so we can go ahead and go up 2 and to the right 1, and there's our next point. And we can go up 2 and to the right 1, and there's our next point. I'm going to go ahead and make this a little thicker. There we go. Up to right one, up to right one, or down to left one, down to left one, down to left one, and so on. Now, in this case, should we make a solid line or a dashed line? Well, let's go ahead and test some points. For instance, right on the line, that red point 0, 1. Will that make a true statement? Let's substitute in 1 for the y value and 0 for the x value. Now, let's test it. What's 2 times 0? 0. What's 0 plus 1? 1. True or false? 1 is less than 1. No. That's a false statement. Let's try another one on the line. Let's try the point 4, 9. That's the point way up near the top of my graph. Let's figure it out. Substitute 4 in for x, substitute 9 in for y. 2 times 4 is 8. 8 plus 1 is 9. True or false? 9 is less than, no. It's equal to 9, but it's not. Okay, let's try another point. Let's try the point, -3, -5. Let's see about this one. Now, you probably already figured out by now. It keeps being the same exact number, but that makes a false statement. So, because this is a false statement, we cannot draw those points as if they're okay. So we're going to have to draw a dashed line through this. And of course, I need to make sure that I have my arrowheads on the end, just because our coordinate plane stops doesn't mean number stops. It keeps going on infinitely. So the first step is to draw the line as if it were an equal sign to x plus 1, but because it's not equals, because it doesn't say or equals, it only says less, all the points on the line are false, so we need to make sure we draw a dashed line. All right, now let's talk about shading. We're going to first test the point 0, 0. Now, if I substitute in 0 for both the x value and the y value, it ends up saying 0 is less than 2 times 0 is 0, plus 1 is 1. Aha, that's a true statement. So I'm going to go ahead and I'm going to just start by drawing a dot there. But, you know, eventually you'll only test one point or maybe a couple, but I'm going to keep going. All right. Let's try the point 5, 2. So if x is 5, 2 times 5 is 10, 10 plus 1 is 11. True or false, 2 is less than 11. That would be true. So now we have another solution at the point 5, 2. I don't know why I picked 1. 1, 2, 3, 4, 5. It'd be like right here. Sorry about the yellow box. Let's try another one, shall we? Let's try the point -3, -9. So substitute in -3 for the x value, substitute in -9 for the y value, and we get, let's see, -9 less than -5. Well, that's true as well. Now, folks, I'm going to go ahead and draw a point 1, -3, 2, 4, 6, 8, and -9, but I feel like you're seeing the fact that there's going to be just billions and billions and billions and billions and billions of points on this side of the line. What about the other side? Well, shoot, let's try it, huh? Let's try another point on the other side. Let's try the point 0, 9. So way up here, way up here. All right, let's substitute it into our inequality. So 2 times 0 is 0. 0 plus 1 is 1. True or false? 9 is less than 1. Well, that doesn't work. All right, let's try a different point. Let's try -3, +3. So it's in the second quadrant. So substitute that in. 2 times -3 is -6. Go up 1, -5. 3 is less than -5. That's another false statement. Okay, let's try something directly on the x-axis, but again, it's above or to the left of the line. Let's see here. We have 2 times -8, -16 plus 1 is -50. Yeah, 0 is not smaller than any negative number. And so the point being here, ladies and gentlemen, that doesn't work. That doesn't work. That doesn't work. that does, even a point super close to the line but above it or to the left, none of those points are going to work. And therefore, because we can draw infinitely many points below or to the right of the line, we are then going to color shade in that whole stinking thing. So we have a dashed line through the line 2y equals 2x plus 1. We have a dashed line. And we have all the points below or to the right are solutions, so we shade those in. Sorry about me shading in yellow. I should have chosen a different color. Sooner or later, you're going to pick one point and you're going to shade. Quite frankly, my advice would be to always do 1 point on one side and 1 point on the other. So if you see that's a true and that's a false, it just takes away the possibility of error. All right, let's roll on, shall we? So y is greater than or equal to 2x plus 1. First step, act like it's just an equation. There is no number at the end, so that means our y-intercept is 0, the origin. Then we're going to use our positive 1 to 2 to go up 1 and right 2, up 1 and right 2, up 1 and right 2, and so on. Of course, we could also go down 1 and left 2 and still have a positive slope. Now, the point, though, is it's not an equal sign. It's a greater than or equal to sign. So should we color it a solid line or leave it open? So pick some points on the line. Let's just pick the point 0, 0. 0 greater than or equal to 1/2 times 0. Well, because of the or equal to, that's true. Let's pick another point. Let's pick 6, 3. So let's try 6, 3. 3 is the y value. Half of 6 is 3, true or false? Well, again, because 3 is equal to 3, that's a true statement. And folks, all the points on this line will be true. So what we're going to do is we're going to draw a nice, thick, and solid line through those points. Which almost drew a line, huh? Now, we're going to try the point 0. Oh, shoot, we already tried the point 0, 0. That's not either side of the line, that's directly on the line. So we're going to have to pick a different point. And when you pick a point, folks, make it a nice one. So I'm just going to pick, just for kicks, I'm going to pick, should I pick 1, 1? Yeah, why not? So back to the inequality, y is greater than or equal to 1/2 of the input value, x. Let's substitute 1 in for x, and let's substitute 1 in for y. Half of 1 is a half. True or false? Well, that's definitely true. Which means, I'm going to go ahead and guess, and I hope I'm right because I'm going to draw a lot of points. We're going to see all sorts of, if you try any one of those x, y ordered pairs, they're going to work, including the points directly on the line, right? Which is why we drew a solid line. But for kicks, actually for checking, let's pick a point that is below the line. And again, pick something nice. Don't make it too crazy. Let's pick the point 4, -2. So for the inequality, sorry, it's getting a little small here. Substitute in -2 for the y value, substitute in 4 for the x value. Half of 4 is 2, true or false? -2 is greater than 2? No. Is it equal to 2? No. So that will verify that the points below the line do not work. You can try any ordered pair below that line, it's not going to work. So in the end, if I could just tidy this up a bit, we drew a solid line directly through the equation y is equal to 1/2 x. Because it had that or equal to, we drew the solid line. And a little highlighter now, shall we? All the points above this are solutions. So we go ahead and we shade in everything above. All the points down below will not work. All right, pause if you need, rewind, watch that part again. I'm going to keep going. Practice problem. Y is greater than 2x minus 5. Let's go ahead and pretend that's an equal sign. Starting value, -5. So let's put that -1, -2, -3, -4. There's our starting value. All right. Slope, let's go ahead and put a 1 under there. So our slope is a positive 2 to 1. That means starting at our y-intercept, we go up 2 and right 1, up 2 and right 1, up 2 and right 1, and so on as much as we can. We could also go down 2 and left 1 and still have a positive slope. All right. Remember, if I pick a point straight on the line, like the point 0, -5, is it going to work or not? You end up with -5 is greater than -5, which is false. Therefore, we take out our straight edge, but we draw a dashed line through this. Sorry, I'm not happy with the ruler for my smartboard right now, so I'm just going to do that. Because none of the points on the line will be solutions, we want to display that and not color it in, not make it solid. That's why we use a dashed line, because of the greater than. Now, we're going to pick a point. And as always, 0, 0, always a good idea. Substitute in 0 for y, substitute in 0 for x, and let's see. 2 times 0 is 0, minus 5 is -5, true or false? Sure is true. So that one looks good. Now, just for kicks, let's try something on the other side. I'm always going to try one on each side. So let's try the point 5, 0. Now be careful, because 0 is the y-coordinate that I chose, and positive 5 is the x-coordinate that I chose. So make sure to put those in the proper place. All right, 2 times 5 is 10, 10 minus 5 is 5, 0 is greater than 5. False, which just verifies that nothing over there works. So I'm going to go ahead and grab my trusty highlighter, and I'm going to go real big. All the points above or to the left, or above and to the left of this dashed line will work. And also remember, none of the points directly on the line work. That's why it's a dashed line. If you just go a hair above, if you pick any x-coordinate, y-coordinate that is above, it's going to be okay. But the points on the line are false, and the points below the line are false. Now, you just heard me say above and below, and that's what we need to focus on. The region above the line is the graph of the following inequality, y is greater. Now think about it. Pick any point on this line. So in this case, the y-coordinate is 1. So where are all the y-coordinates that are greater than 1? Up here. Look at this point on the line. Where are all the y-coordinates that are greater than that? Up there. Look at this point on the line. Where are all the y-coordinates that are greater than that mixed number? Above. In other words, when it is greater, you should be shading above. So when do you shade below? Well, below would be the points below that line. And really, I should have drawn a dashed line. I'm sorry about that. This should be a dashed line. But if you look at those points that I just chose, if this y value is -2, where are all the y values that are smaller or less than -2? They would be going down and down and down and down. So that could give you a little tip to check yourself. We're still going to check 0, 0, and probably another point, but that could help you in terms of shading. All right, so now let's go ahead and practice. Again, you should have a practice paper on your notes. I'm putting in a number of solutions here, but I would still encourage you to maybe even ignore the graphs below and try to graph on your own y is less than -3x plus 4, and then come back when you're ready to check it. Okay, so first thing we notice, there is no or equal to bar. which means it can't be either of these top examples. So that's the first thing I'm going to do. I'm going to X those out. Cannot be those. All right. Now both of the lines below are dashed lines with a y-intercept of 4 and a slope of -3 to 1. But we are looking for all the points that are smaller or less than that relationship. And therefore, if you think about the line, where are you going to graph? You're going to graph down. And so the bottom left example is the correct one. If you've graphed it on your own, if you haven't, go ahead and graph that right now. Again, what we did was we graphed the line. Whoops, that went to a highlighter for whatever reason. We graphed the line y is equal to -3x plus 4. We made it a dashed because it's not really equal. It's less than. And then we shaded in all the points that are in fact smaller. If you tried the origin 0, 0, it would make a true statement. If you tried any point on the other side, like 10, 10, it would make a false statement. And so the correct graph is going to be bottom left. All right, let's do the same thing again. Let me put a screen shade up real quick. Don't look, don't look, don't look, don't look. Okay, go ahead. On your notes page, I would like you to graph the line for y is greater than or equal to 4/3 x minus 6. Decide if the points on the line are solutions or aren't solutions. If they are, color them in as in a solid line. If they're not solutions, leave it blank as in like a dashed line. And then decide which way you shade. Go ahead and hit pause. Come on back when you're ready. And so we have the following possibilities. The first thing I notice, because of the or equal to sign, it can in fact be on the line. So I immediately cross off the left two examples that have dashed lines. The lines, the point on the lines, all the infinite points on the lines could be true. And so it's got to be one of them on the right. It's got to be a solid line. Okay. Where would all the y coordinates be greater than the points on the line? Think about where the y coordinates get bigger and bigger and bigger. And it would appear that this example is our lucky winner. Now, for those of you that tried the point 0, 0, if you were to substitute in 0 for x and y, it would be a true statement. 0 is greater than or equal to -6. That is true. So that's just another verification that this is the side that should be shaded. If you were to try at any other point, like something way down here, 8, -8, substitute, or not, let's try 9, -9, right? So substitute in 9, substitute in -9, you would get, let's see, 1/3 of 9 is 3. 4/3 of 9 would be 4 threes, or 12. 12 minus 6 is 6. No, Mr. Callan, -9 is not greater than -6. So just a verification that the points on the other side don't work. So in those last examples, folks, what I did was I gave you an equation, or excuse me, an inequality, and I asked you to create its graph. Now can we go backwards? Can we start with the graph and write its inequality? So I'm going to ask you to hit pause. Please recall that anytime you don't have a coefficient, you're always welcome to write a 1 there. And of course, anytime you have an integer slope, you're always welcome to write a 1 in the denominator. Go ahead and try to match each of those up. And if you want to graph them out on the back side of your notes, you're welcome to do that. Hit pause, come on back when you are ready. So I'm going to start with the blue one. Blue one has a y-intercept of +2. Well, guess what? They all seem to have a y-intercept of +2. So that's not really going to help us, is it? Now, blue one does have a slope of -1 to 1, so I got to have a negative slope. Therefore, I'm looking at the bottom two examples. And the blue one is greater than or equal to, so I should have a solid line with shading up above that line. And so that one will match up with the bottom right example. Solid line, shading above. All right, let's move on. Purple example, a 1-to-1 positive slope. So I'm only going to be looking at the top two possibilities. Solid line with shading that should show greater than or equal to, meaning all the points above that line. And so what I'm seeing there should work out for us. Green example, solid line, negative slope. And we're looking for all the points that would be less than or equal to. And so naturally, that one will go with this one. Again, solid line, y-intercept of 2, negative slope of 1 to 1, and all the points on the line work. That's why you draw it solid. And we're looking for the points that are less than or equal to, so we shade it down. Last but not least, you already know where this one goes. Y-intercept of 2, slope of 1 to 1, less than or equal to, and so there we go. That will be the first part of your homework, folks. We're going to start you off with the graphs, where you will be asked to write the inequalities. And following that, you're going to actually graph them out. Now, I did give you paper on Thursday in class. Therefore, use your paper, please. You're probably going to want another piece of scratch paper just to do the first few parts, 7, 8, 9, 10, 11, 12. And then graph 17 through 20 using the paper that I've been given. So this assignment is for Monday. Let's see, Monday will be May what? Uh-oh, somebody completely erased my board. I think it's the 10th. Forgive me. I don't have my watch on and my board is gone. How about that? So take care, do well, bring some questions on Tuesday, and let's grow. See you, folks.